Hello students, right here again today. We've got practice problems for review. As always, they should be completed, and now you'll be checking your answers and correcting them. Number 15, why were Dalton's ideas about atoms considered a scientific theory where ideas of ancient Greek philosophers were not? Key idea here, Dalton's ideas were based on experimentation and the ancient Greeks were not. Why was the discovery of electron considered evidence for the existence of positively charged particles in the atoms? So, electrons were negatively charged. Atoms were neutral. So there must be positively charged matter to balance the charges out. As always with these questions where you're explaining something like this, first couple questions, a lot of different ways you could explain it, but you should have the basic ideas I'm talking about, something very close to it. What would scientists conclude that most of the atom's mass is concentrated in a very small nucleus? What particles are responsible for that mass? Rutherford's gold foil experiment gave evidence for the nucleus. And protons and neutrons make up the mass in the nucleus. Number 18, explain the relationship between the number of protons and the number of electrons in an atom of argon. The number of protons equals the number of electrons in all atoms. For argon, there are 18 protons and 18 electrons. Again, two different atoms atoms of two different elements have the same number of protons. Definitely not. As number of protons in an atom define the element. What particles make up an atom of selenium-80? The selenium-80 is Sc. I'll put an 80 up here. I'm going to write the formula for it. And selenium is element number 34. So I'm going to put a 34 down here. So that's its formula, but that then indicates, because it's element number 34, has 34 protons, 34 electrons, and taking 80 minus 34, we get 46 neutrons. And number printed at the bottom of each box at the periodic table. Is the average atomic mass, which is the weighted average of masses of all of the isotopes. All of a naturally occurring isotopes of an element. And write the symbols for the following isotopes. Antimony, Sb, which took that 123 up here, its mass number. Look it up on the periodic table, and antinomy's element number 51. Silicon, Si, mass number 28, atomic number 14. Mercury, Hg, mass number 199, and atomic number 80. And completing the table, types of radiation, we have gamma, and we also have alpha and beta. The electron is the beta particle, and then this one must be alpha. Mass of beta particle 1 over 1,840. The mass of an alpha particle is 4. The helium nuclei, 2 protons and 2 neutrons, which is its composition. 2 protons, 2 neutrons, that's why the 4. Charge is plus 2 because of 2 protons. Charge of a beta particle's electron is a negative 1. Gamma particle has no mass, has no charge, and it's energy only. So that takes care of practice problems for Chapter 4, the review part. I'd be getting really close to being ready for a quiz now. Make sure you know all the material for Chapter 4 can do well on the quiz. That's it for now.